Our next lesson is titled Outcomes of Compound Events. So a compound event is the combination of two or more simple events. A tree diagram is an organized diagram that lists all possible outcomes of compound events. And the fundamental counting principle says if one event has m possible outcomes and a second event has n possible outcomes, then there are m times n possible outcomes for the compound event. For example, if we flip a coin and then roll a die, flipping a coin has two possible outcomes, heads or tails. Rolling a die has 6 possible outcomes, 1, 2, 3, 4, 5, and 6. That means if I do those two things back to back, there are 2 times 6, or 12 total outcomes. Example, at camp, each camper gets one sandwich for lunch. The meat choices are turkey, ham, and roast beef. The bread choices are white, wheat, and multigrain. If one of each type of sandwich is on every table, how many sandwich choices are on each table? So there are two ways we can go about figuring this out. 3, really. First is to make a list. So for example, we could have a turkey on white. We could have a turkey on wheat. We could have a turkey on multigrain. Those are the possibilities for turkey. We could have ham on white, ham on wheat, ham on multigrain, and we could have roast beef on white, roast beef on wheat, and roast beef on multigrain. That is a list. That's all the possibilities. There are 9 different sandwich possibilities, so there's 9 sandwiches on each table. We've answered the question, it's 9. We could, instead of doing this list, make a grid to see the possibilities. So we could say put the meats on the top, so ham, turkey, and roast beef. And on the side, we could put the bread types, white, wheat, and multigrain. Now we don't even need to fill this table in. We can see there are 1, 2, 3, 4, 5, 6, 7, 8, 9 possibilities. What if pumpernickel is added to the bread choices? How many sandwich choices would there be now? Okay, now this time I want to show you the fundamental counting principle. So how many meat choices are there? Well, 3. We haven't added any to that. It's still turkey or ham or roast beef. How many bread choices are there? Well, now there are 4. White, wheat, multigrain, and pumpernickel. So how many combos are there? The fundamental counting principle says I can do 3 times 4 and say there are 12 combinations. Tomas chooses a sandwich at random. What's the probability he chooses ham on wheat bread? And for the record, this is from the original list. Okay, so this does not include pumpernickel. So he chooses 1 sandwich at random. What is the probability he chooses ham on wheat? Well, in the entire list, there's 1 that's ham on wheat. I just went up and circled it. So there's 1 ham on wheat, and there are 9 sandwiches on the table. So the probability he chooses ham on wheat is 1/9. Draw a tree diagram to see the possible outcomes when flipping 3 coins. Okay, so here's our first event. We flip a coin, and it lands, and I'm going to space those out a little bit. it lands heads or tails. But then we flip it again, and it lands either heads or tails again. But then we flip it again, and it lands heads or tails the third time. What this is showing me is I can follow these paths if I want, and I could say, okay, the topmost path is H, 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 heads, heads, heads. I could follow that path again, but instead of going top, 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 I could go top, top, bottom, and have heads, heads, tails. The total number of possible outcomes is just the total number of things on this right edge. So there are 8 total outcomes. Last, use the fundamental counting principle to determine the number of possible outcomes when flipping 3 coins, then find the probability of flipping 3 heads. So we already know there's 8 total outcomes, but the fundamental counting principle says I can find that by doing, watch this, I'm going to flip a coin 3 times. So the first time there's 2 possible outcomes, times the second time there are 2 possible outcomes, times the third flip there are still 2 possible outcomes. 2 times 2 is 4. 4 times 2 is 8. Now, how many different ways can you flip 3 heads? Just the one. Heads, heads, heads. There's only one way you can flip 3 heads. There are 8 total outcomes. So the probability of flipping 3 heads is 1/8.